Hey guys, I got a super show for you today. I am talking with Dr. Rebecca Schwarzlose. She is a neuroscientist who just wrote a book called Brainscapes, the warped, wondrous maps written in your brain and how they can guide you. Super, super smart lady and super nice. This is a great conversation about the wonders of your brain and the maps that guide the wonders of you. Pull up a chair and buckle up. It's the Original Strength BodCast. So, Rebecca, congratulations on your new book,
Thank you.
Brainscapes. This just came out, and you've probably been pretty busy. How many radio shows and podcasts have you done so far about the book?
Um, I think 4 or 5 now.
Oh, some
And then I
early.
have some more scheduled as well. So it's been really, really fun and exciting to be talking about it with people. Yeah.
It's pretty neat, right?
Yeah. Feels good.
How long did it take you to write Brainscapes?
I shudder to disclose this, but I think from start to finish, from the idea to today, it was a little over a decade. I mean, it was a long
Really?
time. Yeah, I didn't work on it consistently throughout that whole period of time. I had years where because of work and because of children and other things, it was sitting lying dormant. But even when it was dormant, I was thinking about it and I was taking notes and kind of making a mental map in my head of what I wanted it to be.
So really, you're saying the brain is so complicated. It took 10 years to assimilate all this, digest it, and then put it back out.
It probably says more about my inefficiency than my brain's inefficiency. But it is complicated. Yeah. No, in my case, it's just, it was making the time and also sort of reaching a point in my life and career where I could really dedicate that time to writing it.
So 10, roughly a decade. How how does it feel like that you got, because it's your baby, right? Kind of, and it's out there, so it's real now. How does that feel?
Oh, I have to say when it's been such a long time coming that there are ways in which it's kind of amazing it's only just now coming out. But then so you could feel a little jaded and feel like you've been waiting so long it's a sort of anticlimactic, but it's really not. When those first copies, a box of copies arrived at my doorstep, I just almost started crying, and I really felt like, I mean, I have two real live children. But I really did feel like, the store could come by and deliver this third baby for me that I had spent so much more time making. But now it was like a fully fledged creature that was going to be out in the world. And it was really an exciting emotional experience. So yeah, it surprised me how it hit me when I had one in my hands.
That's really awesome. And I get it. Like there's really nothing like it because you created something, and now people are talking about it. I mean, it's out there.
Yeah, it's exhilarating. It's exciting, and it just makes you feel like that time was worthwhile, and that hopefully people can come away reading the book feeling like they understand themselves and their world and their brain better, and that just makes me feel really good about the time that I put into writing it.
So you're passionate. You love writing,
I do.
and you're a neuroscientist who seems somewhat passionate about the brain, passionate enough to put your two loves together, and to share it with others. What got you into, what made you decide to write about the maps inside the brain?
Yeah, so in my graduate studies, I was working on object recognition. So I was doing a neuroscience PhD. I was working in the lab of Dr. Nancy Kenwisher, who's a fantastic, amazing scientist at MIT, and we were looking at the properties of a certain area of the brain that is highly responds strongly to faces, and is very important for face recognition. And there was some existing evidence that there was also potentially some representation of body information. So the visual information about, hands, whole bodies, feet, the things. And so what I as I explored that, this was my first graduate study project. I discovered, that I could show that that was a separate area right next to the face area. There was actually like an area that was dedicated to processing images of body parts, including hands and feet and torsos and everything. And that really got me intrigued. Like, why are these areas right next to each other, like kissing, just right so close? And so that really got me to think about layout and sort of what drives the organization of areas and representations in the brain. I started to study more broadly what is known about these principles, and how these kind of maps develop in our brains, and why they're there, as far as we know. And so I just kind of became obsessed with it. It was just so cool and so interesting. So that was the early origins of Brainscapes.
So if you're listening, guys, there are brains in your map, and they represent areas of your body and qualities of your body. Can you explain how that kind of works?
Yes, yeah. And actually it's not an easy concept, which is why I kind of dedicate the first chapter to explaining what I mean by a brain map, an actual map in your brain. And I really kind of describe it like this. So in your brain is made up of cells, of neurons, and if you take the analogy of a piece of paper, a map on a piece of paper, your brain cells are like the wood pulp in that paper. They're actually what make up the physical map. But instead of representing information with pigments of ink, our brain maps represent information by electrical signals, which is how neurons communicate with one another. And the rate at which a neuron is firing is its way of representing a particular aspect of your perceptual experience. And so what's kind of amazing about these maps is that they preserve layout aspects of your experience literally across the surface of your brain. So an example, it really is helpful to think in examples. So an example that I start out with is we're very visual creatures. So I start out the book talking about our visual maps, and kind of the biggest visual map that we have, which is called primary visual cortex, or V1. And it's at the very back of our brain. And it's divided across the two hemispheres at the back. And what it does is it represents the light that is falling upon our eyes, falling upon our retinas and our eyeballs, all relative to where we are directing our gaze. And so the activity in particular neurons, the actual rate at which these neurons are firing, and the spatial layout of these neurons is preserving the information that is falling on your retinas, which is what you're looking at. And so there have been studies that have used kind of methods where you can sort of stain the brain and make visible where brain cells were active, or you can put a person in a brain scan, and you can scan them while they're looking at something, and you can actually see across the surface of the brain the patterns of what they are looking at. So that's how, we as neuroscientists can now render these invisible maps visible. But they're all throughout the brain. And that's just one example. We have maps that are kind of roughly laid out according to the surfaces of our body, and they reflect the touch information that's coming in from touch receptors in our skin. We have maps that are laid out according to frequencies of sound, which we detect with our cochlea. And there are maps that represent the movements that we make in our everyday life. And there are maps that represent the spaces around us to which we, attend and interact. And these are all this incredible architecture that allows us to do and perceive and act easily, fluidly, and consistently from day to day.
So for the touch map, or the surface area map, is that like the homunculus? Like, would that be a representation of the homunculus?
Yeah. So for people who have maybe taken Psych 101 or have had some experience with that, or have just kind of seen in popular culture that the sensory, there's two of them. There's the sensory homunculus, which is a kind of a person whose
End of a
body
person.
it's pretty wild to look at, right? Whose body parts are distorted according to the way that the primary sensory touch map is representing them. And what that means is that in the subtitle of my book is the warped wondrous maps. And that's because these maps are warped, and they allocate a disproportionate amount of their territory to representing certain parts of our experience. And in the case of touch, that is our fingertips, our hands, our faces. So we are therefore able to detect just a far greater amount of information and kind of detailed information on those surfaces of our bodies, which in turn shapes how we interact with the world. And we don't feel things with our feet. When we want to feel something, and get texture information, we always use our hands. So that kind of capacity, that sort of sweet spot for touch, is very useful for us, but it's also helpful for our brain in terms of, our brain couldn't sustain us being that good at feeling with our entire body.
That's what I was going to ask you. Because like, so the head is big, the lips are super large, the hands are large, and the feet are somewhat large. So it's very goofy looking. But those are the things we use the most.
Yes.
Especially in our, sensing things, feeling things. But like, so when a baby's developing, they have a lot of sensory information going in through their forearms. And I think we lose roughly 80% of that as we, get off our forearms and get up on our feet and stuff. So I was wondering, could you take the really grotesque looking cartoon homunculus, and would there be a way to make it more proportional, by using the rest of your body to start putting that information into the brain? Can you change the maps? Can you make them more clear, better? I don't know. Just a question.
It's a great question. And, so to some degree, the map is shaped by evolution. And so the initial basic layout of the map is driven by our genes and our these chemical signals that are set up in the developing brain that drive the initial layout of these maps, including the tactile touch maps. And that's actually part of why we have such sensitive faces, even though we don't really do a lot of touching with our face, is because we evolved from animals who walked on their four legs. And, most mammals do all their feeling with their face, which is why I have some pictures in the book. And I talk about how, some animals, it's their nose that's the most sensitive, or for whiskered animals, their whiskers. Some it's like the sheep, it's the lips. But there's sort of the face area evolutionarily is so important for touching, because that's where animals were able to touch. They were sort of propped up on their forelegs and using them to stand. So we as primates kind of are new in our ability to get up off of our hind legs, use these hands a lot, and certainly us as having graspable hands. We use them quite a bit, so we've been able to capitalize on that. So there's some ways in which the map is already shaped by evolution. So even though we don't continue to use the face for a lot of feeling as modern humans, we still have very sensitive faces. But yes, especially in early infancy, very early infancy, and I do talk about this in the last chapter in the case of rats. If you drastically change the tactile inputs that a creature, and presumably a human, receives, we don't do these experiments in humans, that would be unethical. But so we kind of have to just extrapolate from what we see in studies with animals. But if you're to drastically change the sensory tactile inputs that a creature receives very early in life, then that can indeed change the layout of the touch map in a way that could affect their sensitivity later in life. Now, the question of how much these maps can change as an adult, for example, it's a difficult question to answer. And the answer, I can say that we know that there is plasticity in these maps that continues into adulthood. And so, that's part of why as you do something over and over again, you tend to find that it gets easier. You tend to find that you can get better at it. And part of that is mediated by modest changes in your brain maps. But for the most part, these maps that mediate sensory perception and action are they kind of get crystallized early on, so that the basic layout and sort of basic function is pretty fixed. And so I don't think there are other parts of the brain that are far more plastic. So it doesn't mean that we're done, we're done by the time we're hit 6 months, it's over. But it does mean that, there are ways in which there's kind of different opportunities for growth and for change at different ages. And so, for example, with the maps for movement, the motor maps, I do talk in the book about how there have been studies that, musicians show differences in their motor maps depending on the instrument that they play. And so, for example, if they're like play a stringed instrument or they play the piano, then they can have enlarged hand representations in their motor cortex for the particular hands that they use to play their instrument. But it's been shown that particular extra space that they receive for their hands, that is specifically linked to very early musical training. So musical training, at 5, 6, 7, and then even later in childhood, although you can absolutely pick up an instrument and become an amazing musician, that's not going to be you're not going to see that big difference in the actual motor map layout because it has started to crystallize.
So I got to thinking when you were asking, or when you were explaining evolutionary, how the face is or the head is represented bigger. Does our maps drive our behavior, or does our behavior drive our maps, or is it both?
I love that question. I would say it is both, but I think especially it really depends as well on age. So especially as a child, a very young child, or even a slightly older child, depending on the map, the timing depends on the sort of detail of which map. The actions, the sensory experiences are shaping the map more dramatically. And then as we get older, the maps, it goes more the other direction. So we can still influence the map, but the map is more fixed. And then we are sort of making the most of the more fixed map that we have. And by doing so, we make the most of the areas like the sensitive hand that we have to touch, or the very sensitive, very accurate, clear vision that we have at our center of gaze. We look with that. So we kind of adapt and use the tools that we have, that our brain maps give us, to eke the most information as adults. And as I write in the book, it's easy to think about having kind of crystallized more or less static maps, or more static maps in adulthood, as kind of a bad thing, like you're sort of stuck with what you have. And I don't think it's that at all. I think it's a gift. Newborn babies can't do hardly anything. They're learning so much, but they're not doing anything. And compare that to many other creatures that can do quite a bit when they're born. But when we get older, we need to have some stability in our brain in order to not have to learn everything anew every morning when we wake up. And so, this is our sort of scaffolding upon which we can learn in more complex ways, and upon which we can kind of build the bigger cognitive load that we have to carry as adults.
Yeah, the reason that question came to me is because you were talking about how other mammals, grew and evolved. But then I was thinking, and I don't know, maybe this, I could be just completely crazy, and if so, I'm crazy. But you're a mother, and you have two small girls.
Yes.
And so when my children were little, like it was instinctual where I would just want to put my head to theirs, or I would just want to, like, I would touch them with my face, not necessarily my hands, but I would do a lot of that. And like, and so when you started talking about that, I started wondering, it's like, well, why did I do that? And is that, I mean, you're a mother, you may have done that, or I'm just crazy.
You're not crazy. And actually what I love about that question, so I do the same thing. And honestly, now I still kind of like I like to put my lips on my face on my girls' heads and sort of smell them and sort of feel them on my face. And there are these very sort of very sensory ways in which we sort of connect with the people that we love. And I think especially our children and also our spouses, there are ways in which we're doing this. And part of that, I think, is you're right. Even though we don't rub our face on produce at the grocery store to see if it feels firm, we use our hands for that.
You only do
We
that
do.
once.
Yeah. Well,
And then you got
so
to
but
get out.
that's right. What is this guy up to? But we do have this sensitive face, and so we do employ it for certain things, including our lips for kind of sometimes for enjoying food, and our face for kind of intimacy with the ones that we love. And so even though maybe it doesn't serve the same purpose for kind of discriminating things that it did for our four-legged ancestors, it serves a different purpose for us. And what I think is also so special about that particular action of bringing somebody close to your face is that it allows you to smell them. And as I talk about in the chapter that covers smell, we we are just an untapped well of kind of odor perceivers, odor kind of interpreters, that we do so much more with smell than we realize. And in fact, science is just starting to catch up with the ways in which our behavior is driven by odors that we may not even consciously realize that we're receiving. And there's a lot of social transmission that happens through scent, and there's a lot of social recognition. So when you put your face on your child, you are both feeling them in an intimate fashion that reaffirms to you and to them that you are close and you are kin. And you're also smelling them and they're smelling you, which is actually an important part of early bonding for humans as well as other creatures.
Nothing smells like a newborn baby.
This is true. This is true.
So I don't know if you know yet, because I'm sure you're still growing and learning, but okay, well, how many maps have you found in the brain? Like, not how many are there, but how many have you found?
Oh, well, I mean, I would love to take credit for finding all of these maps, but I cannot.
How many maps do you know about?
I mean, I can't even estimate, because honestly, it seems like every week there is a new map-like organization that is being reported in the scientific literature. But I think it is safe to say that there are, over 100 maps in your brain, and probably more than that, depending on how you count them. Because it's not just in the surface of your brain that you have maps, but also in these subcortical areas, the areas that lie deeper within your brain. These areas also have maps. And so it's kind of remarkable that so many places that you look in the brain, you see again and again different variations on this theme, this map-like organization. So I would feel comfortable saying that you should have at least 100 of these in your brain, especially if you can count the two sides, and probably more than that. And we have undoubtedly not discovered them all.
That's pretty cool. So I asked if you could improve the maps. Can you lose a map?
Well, you can absolutely lose a map by brain damage. And that is actually how we have learned the most about these maps and kind of first discovered them. If you have like carbon monoxide poisoning, or you have a brain trauma, or you have a bullet wound to the brain, you have a major stroke, you can knock out brain maps. And what often we've discovered the brain maps, because what happens when these areas get knocked out is that people lose capacities that they've had all their lives. And so, that can be the capacity to literally visually perceive, so see things. It can be, may still be able to see things, but you may not be able to recognize what any of those things you see are, including your own child or your face in the mirror. You can lose the ability to consciously, recognize what you're hearing. You can lose motor capacity, the ability to make movements. So, you can have profound damage, can profoundly cause you to lose a map. And if you mean in terms of disuse, yeah, right. So, so usually these maps are so fundamental that you don't not use them.
Okay.
But there are instances, for example, there are people who go blind later in life, and there are people who go blind early in life as well. And so for people who go blind later in life, something happens to their eyes. They're no longer receiving visual input, but they have this whole neural architecture, these visual maps that is laid out and ready to go to process information that's not coming in anymore. To some degree, the visual areas of the brain in these individuals is able to start to do a little bit more in other areas. So start to represent a little bit more of other things, but it's pretty limited. But the degree to which it changes can still have an impact for an individual's ability later in life, if they go blind, to become more independent or more capable or make more with the information that they do receive. But if a child is born blind or goes blind very early in life, they can totally reorganize and totally kind of reuse what would otherwise be visual cortex and turn it into something else. And so in instances, you can even, I almost put it in the book, there's these, this is an amazing study that looked at people who were blind in one eye, and they either kind of lost vision very early, like very young, or very late in life. And then they looked, and you could see that the architecture was very different, that, people who'd been blind for 60 years, but went blind at age 20, they still had maps that looked pretty normal, as if they had been, still could see. So that map, in some ways, it's preserved. Many features of it do stay. But again, there is this amount of degree to which we can make more with what we have. And so there is some changes that can be made, and those changes can help you. So by that, I mean, like, disuse, you're not, it's not that you're losing the map, but you're basically, anything that's not being used in your brain is a terrible thing from a brain and energy and survival perspective. So when what I'm talking about is not so much that the brain, like the map will wither, but that other functions might to some degree be able to capitalize on the disuse of that map and use it for something else. And so to some degree that can happen, but as you get older, it becomes less. And by older, I mean just throughout. I mean, by 20, by 20, 25, 30, that's what I mean by older. I don't mean like 80.
Right on.
But again, like I think it shouldn't make us feel like we're stuck. I think it should make us feel, and we have other tools for sort of making more with what we have and sort of changing. But the maps themselves, certainly you can also lose capacities if you don't, use it. But these kind of foundational maps that represent the senses and the movements, thankfully, we usually can rely on them, and they stick around, sometimes for better or worse, right? Even if we don't use them anymore.
So speaking of the worst part, then, is that why, like, say somebody loses a limb, but they still have the representation of it in their brain? Is that what is the, I guess, cause of phantom limb pain and stuff like that?
Yes. So exactly. So you're seeing an instance where you have a region of that map, exactly, that used to process, say, an arm, and used to process touch on that arm, and now nothing is coming into it. And so what happens often is that they're in a sense, because part of what the story of the map is that, things that are close by in the map are interconnected and kind of talk to each other more. The neurons next to each other in a map represent related things and talk to each other. And if the arm is gone, then neurons nearby representing other parts of the body that are next to it in the map begin to communicate with these neurons and sort of capitalize on them. Yeah. And so what happens then is you can have like a mix up where you maybe you have touch on the face, but you perceive it as touch on your arm, which is no longer there, but the rest of your brain is still interpreting that space to some degree as representing an arm. And that is one of the fascinating things about representation in the brain, the way in which these maps work to represent our experience is that they can be in wild and wacky ways divorced from and in very profound and upsetting and disturbing ways, divorced from our actual physical body and experience. And when that happens, it can have major repercussions.
So we have these maps, and now we know about them, and you can map them out. You can figure out where they're at and what they represent and stuff. So for the hope of the future, what does knowing about these maps, how can it help us in the future?
Yeah, that's a great question. So I do one of the things that I think is important to acknowledge that I want to do just first is that it does remind us that it does remind us of the importance of childhood for supporting the growth of these maps, giving children enriched experiences that help to give them sort of diverse brain maps that will serve them well throughout life and upon which they will build those become the foundations for things like reading and mathematics and comprehension of time, like being able to a lot of the skills that we use later are built from these brains that are and the experiences that happen early. So we should as a society want to make it so that every child has enrichment, has a safe environment to kind of experience their surroundings and have that infrastructure on board for the rest of their lives. But I also have a whole chapter where I talk about how we are now using these maps, our knowledge of these maps, to basically read out from the brain, or communicate information into the brain. And so what I mean by that is we can now connect, they're called brain computer interfaces, or BCIs. We can now use these maps as like a portal to either transmit information. So say that somebody goes blind, and in theory, you can transmit information into the primary visual cortex directly, with electrodes. And that information can replace the information that the eyes no longer provide, so that somebody who would be blind can now see, right? And we do something sort of like that, not in the brain, but in the cochlea with cochlear implants. So the idea is that you can kind of generate activity in the brain that will give people the input that they have lost. Or conversely, if they have like spinal cord damage and they can't move their body parts, even though their brain is intact, you can put some electrodes in there, you can listen to those neurons, and if you know what they represent and how they represent it, a computer can listen to their activity and translate that into a movement of a robotic arm, for example, so that this individual could be able to move their body, or at least the robotic prosthetics, in a way that allows them to be more independent. So there's incredible potential for using these maps to empower people who have been sidelined by injury or brain damage, or like external peripheral damage to their sensory organs or their body. So yes, it's like, but it's not there yet. So there's still quite a bit of work to be done to perfect it. Yes.
But it's coming, and it's total Star Trek Next Generation level. Like, I don't know if you know ever watched that, but LeVar Burton, he was born blind, but they, he had the thing that they put on his head that communicated to his brain and it made images for him.
Oh, yes. I was a Trekkie. Yes.
Right on. Awesome.
Yes,
So
exactly. So in theory, that would be one of the goals of these sorts of technologies.
it's coming because everything that has ever come out on Star Trek has happened, from flip phones to how we communicate to computer, whatever. I mean, the only thing we haven't done yet is the teleportation thing. So, but that's coming
Yes,
too.
I'm never going to do that.
Yeah, I don't want to volunteer, but it's only a matter of time, because if we can think of it in our minds, we seem to be able to create it somehow. So it's only a matter of time.
Interesting. Yeah, could be.
So you've got your new baby out and you're watching it take legs and run around. Your book, I mean. What's next? What are you up to now? What are you gonna do?
Yeah. So, well, I'm not planning on writing another book anytime soon. Right now, I am enjoying the book being out, and I am enjoying sharing it with the world. I am focused a lot on my research and getting my research papers out, and so I have been, in particular, actually, I've been focused on psychiatric illness in children, and sensory sensitivity, which is a phenomenon in which children, and also this occurs in adults, have kind of experience distress from sensory inputs that other people might not even notice or might just brush off. So there are ways in which individuals can be particularly affected by their sensory environment, and has been seen, and you see this a lot with people who are autistic, or who are suffering from certain psychiatric illnesses. Also, and often it tends to happen in children identified as gifted. So it's just this kind of this different way of engaging and experiencing the world. And I want to understand what it is and what's causing it, and how it works.
Awesome. What about your blog? Are you gonna pick your blog back up?
Oh, that's a good question. I would like to blog a little bit about the book, because I want to share some of the stories about how it came about, and I want to talk a little bit about the illustrations, which I worked with Paul Kim, is a wonderful scientific illustrator, and he made these beautiful hand-drawn illustrations. And so I thought I might be able to highlight some of those in blogs. But I find that there is so much less time than there are things to do with it. So I probably will never be able to get back to real blogging on a regular basis.
Well, as long as you find a way to write, because what keeps a writer happy is writing. Especially you're expressive outlet.
Yes, yes. It's kind of a compulsion. I think sometimes you just have to do it. So I will do that.
So Rebecca, how can people find out about your book? I will put the links in the show notes. But is Amazon the best place to go, or would you rather them learn more ways to find your book?
Oh,
Or
well,
you?
there's also an IndieBound which will send you to your local bookstore. And Barnes and Noble is out there, and it's I think supporting our brick and mortar bookstores is a wonderful thing when we can. So yes, absolutely. Please check your local bookstore. And I just hope that people enjoy it. I hope that people find a way to connect to it, and that they walk away from the book feeling like they understand themselves and their connection to their environment in a different way. I want to thank the Sloan Foundation for funding Brainscapes. The Sloan Foundation has this amazing program, the Program for Public Understanding of Science and Technology. And it is just a wonderful program for helping scientists and science writers communicate science to the general public, which we obviously need more of. So they were wonderful in helping make this book possible.
That is awesome. I will put that in our show notes as well. Guys, if you're listening and you've ever been curious about the wonders going on in your own head, the wonders of your brain, do yourself a favor and check out Brainscapes. Dr. Rebecca, thank you so much for being on the show.
Thank you so much, Tim. I really enjoyed it.
Thanks for listening, everyone. Have a great weekend.